Hello,
Hello.
hello, Team IAPE 135.
Yeah,
Welcome to the GYSTB 2022. I'm Carlos, the MC of this judging panel. This is team from Ireland, and the project title is Building an Automatic Weather Satellite Ground Station with Data Analytics Forecasts. So first,
yeah,
thank you for you for joining us today and your efforts in developing this science project. So today we are glad to have Professor Ho from the Chinese University of Hong Kong and Professor Zhu from City University of Hong Kong to be our judges in this competition. Please note that this window will turn into a countdown timer when the judging officially starts. You have 5 minutes to present your projects with screen
yeah,
sharing of PowerPoint or other materials. We will remind you the time after 5 minutes, and you have to start the presentation when the time's up. And there
yeah.
will be 4 minutes for Q&A sections after the presentation. So this is the flow. Do you have any questions?
No, I'm fine.
So if you're ready, please share your presentation materials. Share your
All right.
screen or PowerPoint.
Can you see it?
Yes, we can. Yes.
Okay.
You can change it into presentation mode.
Yeah.
Okay, that's great. So you may start now.
Okay. So my project is building an automatic weather satellite ground station with data analytics. So basically, I started this project because I was always interested in space and technology, and I saw an opportunity to do a project. I just started researching this topic. I wanted to learn about satellite communication, so I came across NOAA satellites, which you can get signals from with an antenna. So my mission became to create a cheap but also effective and automatic method of weather prediction and analysis system that can be used by anyone who needs automatic like weather updates, such as like people living in the coast or fishermen with like limited internet access. So I'll have an opportunity to learn about the software and hardware infrastructure and the technology behind satellite communication. So the first step I took was to build a Gfh antenna. It's a quadrifilar helix antenna. It's basically this here. It's made of copper tubing and it has plastic tubing and has copper wires and a coax cable, and they're all joined up at the top here. These antennas are just used to receive signals from no satellites. Then I used an SDR this year. This just converts the analog signals from the antenna into a format that the computer can understand. And then I used a Raspberry Pi, which is a small and power efficient computer. It can be run on a solar powered battery bank, so it's very sustainable. I downloaded all the applications that I needed and set them up. So basically input my coordinates and altitude and such. So the applications will know basically where to put the overlay map. And then finally, I have to configure that data analysis based on historical weather data. So I use a simple Python program to input all the data so we can compare past and future data. This is just a basic architecture of the process. So the satellites feed the data into an antenna. The SDR converts the antenna data into a format that the Raspberry Pi can read, and then the amplifier just like boosts the signal. The battery pack powers the Raspberry Pi, and the scripts all work together, and then at the end you get a weather image. This next slide. So this is the process flow diagram. So predict is an application, is the application used to predict where satellite will actually come and when as well. So you feed the data there, and then after you get the base station info, which is basically our own location, it downloads past information based on where you are at, so it can know when to start recording and when to convert the signals. Then after all that, at each time the satellite is overhead, it'll start recording based on the given information. Finally, the audio is recorded using an application called SOX, and then it's converted into a .wav file, which is like .mp3, it's just another audio format, and then WX to IMG is a application used to convert the audio file into an image, and then this is the data analysis process. So it's still work in progress. I just need to do a bit more research. You get the weather data and then you input them into the generation script. You can also get the past data from old like data analytic libraries and plot libraries, and you get an image like this. As you can see, it's a bit compressed, which is why I need to do a bit more research on this topic. It's you don't use using Python, and then here are the results. As you can see, you can see clouds in the middle of Europe, but it's full of static because of the bad weather in here in Ireland. And hopefully, since it's the summer, I'll be able to get better results, and then do improvements to the antenna as well. And then in conclusion, I was able to achieve my initial goal, which was to learn more about satellite communication. And then I got, since I didn't have a huge budget, I was able to make this whole project under €100 budget. And during this research, I learned loads about how satellites work, how we can communicate with satellites and such, and all about troubleshooting as well. Just I had to go through many different problems now. Finally,
Oh, sorry, team. Time's up. Thank you very much for your project. So let's see if the judges have any question on your project. Thank you.
Yeah.
Very nice work. Very impressive work for what you have done. I mean, your system composed of multiple parts between the hardware and actually the analysis and the data collection. I suppose you did most of this yourself, right? I mean, obviously. Do you have a good understanding why where the static come from, and how can you reduce the static from your image?
So I believe the static is from just the bad weather here in Ireland. So it's mostly cloudy and rainy all the time. So now that it's the summer, I'll be able to get better results. And also, I'm hoping to do improvements to the antenna, just like a better design, hopefully. And then that should, in theory, reduce the static and get a more full image.
So the static might be obviously the weather is the reason, right? But the physics of the static is what? I mean, because of the too much static electricity in the atmosphere that's creating the static, or so that's something that you need to think about, look into a little bit deeper, right?
I think the static is just because of the clouds blocking the signals. So with the amplifier, I can boost the signals, but I also need to properly research the booster as well. So then software can read it properly.
Exactly. You need to start thinking about how to reduce static in the collection. I mean, that obviously that's something that you have done for many in the microwave research have done a lot, right? Essentially, to put bubble shielding and grounding and so forth. There's something you can look into to improve your system. I think once if you can done that, then it will be very interesting device that you have developed, right? So okay, so that's all my question. Professor Ho, do you have any questions?
Right. Thank you, Professor Chu. Very nice work, and it's very, very capable. I mean, in terms of producing the entire system and the data analysis. Now, I'm actually trying to look at it from the impact angle. Now, imagine you're receiving the same information from the satellite as a government weather prediction agency doing, right? I mean, they are receiving the same data. Now, they are doing analysis as well. Now, me as a user, I mean, I can actually watch the website of a government agency and get the information that I want. Now, what more value does your system offer?
So since we have our own antenna, we can receive the data without internet. So it's for people with limited internet access. So people in the coastlines, and then like people who are like out in the sea doing their job. And also the whole system is built under €100, so it's very cheap and it can go on for a long time as well. It's like durable, like it won't go bad.
Right.
It's like €100 for years.
Right. Right. So what you're saying is, in fact, sort of autonomous, low cost, highly distributed, very remote sensing station kind of application.
Yeah.
All right. Okay. Right. So I'm satisfied. Yeah. Thank you.
Yeah, okay. Thank you.
Thank you. So I have no other questions. So
Yeah, thank you very much for the nice work.
Yeah, very nice
Thank
work.
you.
Yeah.
Thank you for
Thank
your
you.
presentation. So see you later in the exchange activities and the award and closing ceremony. Thank you.
All right. Okay. Thank you.
So
Thank
see
you.
you
Bye-bye.
later.
Bye-bye.
Now. Thank you.
Yeah.